Hi there. Today, our learning target is I can plan an investigation that shows the interaction between a magnet and a magnetic object on various materials. And I can observe and explain the interaction between a magnet and a magnetic object on opposite sides of materials. So we're going to take a look at our achievement level descriptors so that we can see exactly what's expected of us. And we can see here in the distinguished category that it says students should be able to analyze an argument based on experimental evidence to determine if it accurately communicates the differences in function and purpose of an electromagnet and a magnet. Also, we need to be able to refine an investigation used to observe the interaction between a magnetic field and a magnetic object. So today I thought that because we've been working on this standard for a while, I thought that we would review some of the information that we've learned. And then after this, I'm going to post a link to a Safari montage just so that you can fully review. And we'll be taking our assessment tomorrow. So the first key concept that we need to know is that a bar magnet is a permanent magnet. It is always on and can attract iron and other materials. Magnetism results from the spinning of electrons in a material. All electrons spin, and a spinning electron creates a tiny magnetic field with a north and a south pole. In non-magnetized materials, these electrons spin in different directions and their fields cancel out. However, in a magnetized material, the electrons all spin in the same direction. This is an image showing iron filings attracted by a bar magnet, and it shows the magnetic field surrounding the north and south pole. So the Earth has the same type of magnetic field created by a spinning iron core. Only a few materials have the right type of structures to allow the electrons to line up just right and create a magnet. The main material we use in magnets today is iron. Steel has a lot of iron in it, so steel can be used as well. Magnets attract common objects like paper clips, tacks, nails, screws, needles, safety pins, etc. And magnets do not attract non-magnetic materials like paper, copper, aluminum foil, wood, plastic, etc. This is an electromagnet, and an electromagnet is a temporary magnet that is created by sending electricity through a wire coil wrapped around a piece of iron. The more electricity used, or the more coiled the wire, the stronger the electromagnet is. Another thing that we need to know is that bar magnets and electromagnets both have magnetic fields, but they are different in permanence, strength, and uses. Can you please stop? Magnetism is a force that can push or pull objects that are on the opposite side of different materials. Magnetism is a force between certain kind of objects. The force can either be a push or a pull. When the force exerted by the magnet is a push, it repels the other object. When the force exerted is a pull, the magnet attracts the other object. So we're going to take a look at a scenario today. It says 4 students planned and carried out an investigation to observe the strength of a magnetic field. They put materials in between the magnet and paper clips to see how many paper clips they could move. They put their results in a chart. Student 3 says materials impact the magnetic field by making the magnetic field weaker. Student 3 argues the thickness of the desk made the magnetic field weak. Student 4 disagrees and says that the materials don't impact the magnetic field and no material can block the magnetic field, but some magnets are just stronger than others. Which student do you find an error in their conclusions? Prove it is what it's asking us to do. So if we look up here, we can see the materials that they used in their investigation was no material, a cover of a book, a piece of paper, and through the desk. So we're comparing student 3 and student 4 because this is who is disagreeing. So when student 3 used a magnet with no material, he was able to attract 6 paper clips. When he used the cover of a book, he was only able to attract 5. So I'm thinking about the thickness of a cover of a book, and we could be talking about a textbook, so that would mean the material was just a little thicker. And then he's got a piece of paper, he could still attract 6. Through the desk, he could only attract 5. And remember, a desk is made of wood. So in student 3's investigation, it would appear that when he's using no material or very thin material, he can attract 6 paper clips with the magnet. But when he's using thicker materials like the cover of a book or the desk, he could only attract 5 paper clips. So with a thicker material, he could attract less. Student 4, same thing. With no material or a thin piece of paper, he was able to attract 4 paper clips with his magnet. And with a cover of a book or through the desk, both of those numbers are less than the initial 4 paper clips. So it would appear that if he's using a thicker material, less paper clips are going to be attracted. So I believe that there is an error in student 4's conclusion because the thicker the material, the less paper clips he's able to magnetize. So again, today, our learning target, let me go back to it, was I can plan investigations that shows the interaction between a magnet and a magnetic object on various materials. And I can observe and explain the interaction between a magnet and a magnetic object on opposite sides of materials. So looking at that chart helped us understand the interaction between a magnet and a magnetic object with various materials. In your independent practice today, you'll be reading and then you'll be answering some questions. Also, watch the video on Safari Montage.